Welcome back to another exciting chemistry. In this lesson, we are going to learn about solving problem with hydrate and basically getting the formula for hydrate. Now, what is a hydrate? So right here, this whole thing is a hydrate. Now, think of hydrate, think of hydrogen, more important, think of being hydrated, and that is water. And we don't know how many molecules of water are there in this hydrate. And the number of water, the number of molecules of water is relative to the specific number of this part. Now, what do we call this part? What's the opposite of hydrate? Well, without hydrate is anhydrous. Okay, so that is referring to the salt. So a hydrate consists of an anhydrous part, which is a salt, and then that salt is surrounded by a certain number of molecules of water. Now we are going to look at this problem. So basically for this type of problem, it's called a hydrate lab experiment. So basically in here you have an experiment. So basically for this experiment, you have a container that consists of, the hydrate. So I'm going to draw in the blue color just to illustrate that to you. So the blue water right here. And what we are going to do is we are going to evaporate it. We are going to add flame to it. Okay, we're going to boil it and we're going to more like heating it up. So what happens to the water? Well, in this case, the water is going to evaporate. And what's left at the very end is, you already figured this out already. After you heat it for so long, what's left is just going to be the anhydrous part, which is the salt. Okay, anhydrous. There you go. And here the water is evaporated. So that's how it works. So let's look at the data behind this. First, you have the empty container, which is the beaker, right? Or some kind, well, not a beaker, more like a crucible, okay, that contains the hydrate. And then you are going to do this. You are going to measure the mass of the sample, which including the hydrate. So the sample is a hydrate, okay? So that's the hydrate part. And then in the container, and now that mass is 25.8 grams. So what you are going to do is you are going to heat it for a long time, make sure that all the water evaporates. That's why we have first heating, second heating, and third heating. And why do you notice the mass stays the same? Or it should be decreased, right? Why is it decreasing? Well, you think about it, as you're heating up, more water get evaporating, okay? Because in this case, more water is evaporating. And once it's evaporated, all of them, what do you have left? The anhydrous part. So now let's look at this data and how can we use our understanding of stoichiometry to solve for the formula. Well, the process is very straightforward. First, you have to determine the mass of water, right? Keep that in mind. And then from there, the mass of water, you have the mass of the anhydrous part. So keep this two components. Your goal is we're always looking for mass of water, which allows you to convert to mole, right? And then the same thing for the anhydrous part. Once you get the mass of the anhydrous part, of course, now you convert to mole. And then from there, you get the ratios, right? So that is the process behind it. As long as you keep this in mind, this is your goal. How can I get the mass of water? How can I get the mass of anhydrous? And that's all the information you do. So we are going to show you step by step how to do it. But first of all, calculate the mass of water lost. To do that, you have to imagine what's happening here. So the mass of water lost is basically, you have a container that contains a sample in it, right? So we have the sample in the container, that's for sure. We don't care about this because this doesn't have the sample in it. And once we heat this sample, what do we have left? To the point that we have no water left. So this is without water right here. Without water, okay? So if that's the case, we can figure out how much water is being lost. So to find the water loss, all you have to take this one here, 25.8 minus 23.9, because this again is without water. And this right here is with water. So what do we get on the end? In this case, we take in the calculator and we take this 25.8 minus 23.9, and it turned out to be 1.9 grams of H2O. Voila, we get our first information. Guess what we're going to do on the next step? We are going to convert to mole, and that's easy. 1.9 grams, okay, H2O times the mole mass. By now, you should remember that this is 18.02 grams of water, and this is 1 moles of H2O. And we plug in our calculator, and we solve this. This turned out to be 0.105 mole of H2O. So far, we got this information done. Now we are going to focus on that. See? Always go back to this one. Now we go back and determine the mass in gram of the anhydrous MgCl, well, magnesium chloride to be exact. So in this case, you have to think about it. Okay, so you have this right here. Okay, I want to change this to a different color. So you have this anhydrous in this little container, right? After you heat it up, how did you determine this by itself? Well, the question is this: what is the mass of the container? Well, we have that right here. The mass of the container is up here, right there, 22.3, right? So if we can figure out the mass of this, which we did right there, after we evaporated, this is what we get. So this is 23.9. What is the mass of the container? Well, the container itself is what? 22.3. So all we have to do is just take 23.9 minus 22.3. And what do we get? We get 1.6 grams. And this is 1.6 gram of magnesium chloride. There you go. And guess what you're going to do next? You convert to mole, and that's pretty easy. So let's do that. And what is the molar mass of magnesium chloride? Well, using the periodic table, you can figure that out easily, right? If you don't know how to do it, review the video on how to calculate molar mass. So here we have Mg. I'm just going to show you anyway. Okay, so Mg is 24.30 plus 2Cl is 35.450. Okay, we add them up. What do we get? 95.2 gram per mole. So now let's do this part, okay? So we have 1.6. So we have 1.6 grams of MgCl2 time, okay? And what do we have here? Well, in this case, the molar mass, and so this has to be 95.2 grams of MgCl2, and this is 1 mole of MgCl2. Look at that. That cancels out, and we plug in our calculator. That turned out to be what? It turned out to be 0.0168 mole of MgCl2. So when we create a mole ratio, it's always the smallest number on the bottom. The whole point of creating a ratio is we get the whole number. The only way you get a whole number is you have the larger number on top. So versus between these two right here, this one and this one, which one is larger? This one is larger. So our ratio is going to be what? Now we're going back to the ratio. In this case, we have 0.105, okay, moles of H2O, and divided by 0.0168 mole of MgCl2. And that turned out to be 6.25. Now, if you have your answer as like this, 1 moles of MgCl2 times 6.25, okay, H2O, that would be incorrect because this is not a whole number. Because you cannot have 0.25 of molecules. So how do you get rid of this 0.25? Well, 0.25 is equal to what? 1/4. So you have to multiply this by 4. So when you multiply, we have MgCl2, right? This little n right there. So we have 6.25 moles of H2O. How do you get rid of this part? Well, you have to multiply the whole entire thing by 4. So this is 4. And what is 6.5? What is 6.25 times 4? That turned out to be 25, because 6 times 4 is 24 plus another one is 25. So our final answer is MgCl2 dot 25 H2O. And this is probably one of the hardest questions you will see because of that decimal right there. In most cases, you will have to the nearest whole number. So I want to show you the hardest question that you can think of. That way you won't be struggling when you see the difficult question later on. So let's go in and check our answer. In this case, A was the mass that show all the water has driven off, of course, after the last heating. So we have 23.9. What's the total gram of loss? Okay, so we have that is 1.9. And then how many mole is this going to be? 0.105. And the mass of the anhydrous part is what? 1.6 right here. And then the mole is turned out to be 0.0168. And in this case, the number, I accept multiple answer in this case. And in this case, I'm just going to put 25. And our chemical formula is 4MgCl2. And we have 25 H2O. And let's check our answer. And there you go. Isn't that nice? But as you can see, this type of problem, focus on this information right here. Don't get bombarded by other information. Just focus on this information, then you're able to solve the rest. But they will make it more difficult by breaking to smaller part for you. So don't get tricked by it. And as always, if you have question with this type of question, show your work on a piece of paper, copy all the question down and show your work, and put in a forum, and I will help you from there. And we will see you next time on another video.